Yesterday we talked about a initial side and using my handy dandy little diaflicky here. And somebody last hour told me I was holding it wrong, so I was doing this for you guys. Should have been this way. You know, because like here's your x-axis in the first quadrant. No, I think I was over here because it looked right to me, but anyway. Okay, so here's the red is your x-axis, and then the blue and the yellow that's coming up is creating the angle. So, and I'll just say the blue here. The blue then is my terminal side. Red is the initial where the angle started, and then as it moves up where it ends, that is called my terminal side. Everybody with me? So let's say I've created a 30-degree angle right there between the initial and the terminal side. What we're going to be looking at today is called a coterminal, which means I'm going to take the initial side, I'm going to keep the initial side, but I'm going to then rotate it a full, so here I am at the beginning, and I'm going to rotate it a full, how many degrees did I just go? 360 plus an additional 30. What's 360 plus 30? 390. Does it look like, though, that I just have a 30-degree angle if I just held it just like this?
Yeah.
So I didn't even know that I went all the way around. Those are called coterminal angles, meaning the 30 degrees and the 390 degrees have the exact same initial side and the exact same terminal side. But they just have some whoop-de-woos going on in the middle that I don't want to say we don't know about, because we will know about it, and I'll show you how we will know about that here in a second. But that's called a coterminal angle, where they have the same terminal side. Okay? The same terminal side. So what we're going to do on our notes, we're not going to draw it as of yet. We're just going to calculate how to find a coterminal angle with an existing angle. So right now, I have an existing angle of 60 degrees, correct? All right, so it's like this. Okay, there I am, 60 degrees. I want to find another angle that ends up exactly in this exact same position. So what should I do with that 60 degrees? Add to what? Add to 360. Okay, so I'm going to take 360. I'm going to do a full revolution and then an extra 60 to it. So you're going to get 420. That is called a these are coterminal, 60 degrees and 420. They have the exact same ending position. Okay? They have the exact same ending position. 150. I'm going to take a full revolution of 360 degrees, and I'm going to add it to the existing 150. And I'm going to get 510 degrees. And if you don't have a simple calculator with you, you may want one, because everything that we're going to be doing is going to be adding or subtracting 360, some with 180 as we go through. So if you need to stock yourself up with that, feel free to do so. Now as I look at C, I have 495. Now I could continue on and still continue to add 360 to that. But since it's greater than 360, I can also subtract 360, and I will still get a coterminal angle. And I end up with 135 degrees. Now please know, I could have added for still, been consistent, but since it's greater than, so 135 is over in the second quadrant, and so if I did a full 360 around it, I still would end up at 135. Okay, so it's still the same, or excuse me, I start at 135 and do a full 60, I end up at 495. Okay, 372, that again is bigger than 360. So let's just take 360 so we have just a more manageable angle. Subtract that, and I have a 12-degree little bitty angle compared to what we've been looking at, a 12-degree angle. Okay? So that's if the degrees are given. Now we're going to be looking at if radians are given, and we were looking at radian conversion yesterday. This is not hard. It's just a matter of converting it to degrees first. And since I have a pi in the numerator, I'm going to put pi in the denominator. I'm not sure if it's apple or cherry or chocolate, but pi is going to go in the denominator. My degrees are in the numerator because that's what I want it to get to. So my pi's cancel. And if you need to, you can take 7 times 180 and divide by 4. And you should get 315 degrees. This is what we talked about yesterday, Alex. We're converting from radian measure. It's just a different way in which to look at angle measurements. Radian measure to degrees, and we multiply. It's just a flat out conversion, 180 over pi. And so then 7 times 180 divided by 4. So that's 315 degrees. I want my coterminal angle. I will add 360 to that. And you should get 675 degrees. F, we want to convert to degrees first because I'm in radians. I know I'm in radians because that pi symbol. So I know pi needs to be in the denominator so that they can cancel. I'm going to multiply by 180. Pi's do cancel. So on the calculator, you take 18 times 180 divided by 4. You should get 810 degrees. Abby?
How do you know it's 180? Is it always?
Always, always. To go from radians to degrees, it's always, that was on yesterday. Okay? Now this is greater than 360, so if you so choose, we can subtract so that we get a angle measurement that's a little bit smaller. 11 minus 6 is 5, 7 minus 3 is 4. So I get 450 degrees. Now I don't have to keep going. Like on one of the other sheets, we had to get it to what was less than 360 to see how many rotations. All I'm looking for is just another coterminal angle, so we can stop at the 450. That's okay. G, this is fun. Let's now multiply by 180 over pi because I want my pi's to cancel. 180 divided by 12 is 15 degrees. 15 is way small, so I will go back to adding 360, and I end up with 375 degrees is coterminal with 15 degrees, meaning they have the same terminal side. 375 just has a full rotation involved in it. It's kind of like, you know, like if I was ice skating at the Olympics, I would skate up and just face the judges. And then you have, I'm trying to think of an ice skater's name that would come up. Who? Nancy Kerrigan. Oh my gracious. Nancy Kerrigan come up, but when she faces the judges, she's done a couple spins in between time, but we both ended up facing the judges. That's the terminal side. She just had a couple extra spins in hers ending than what I did, and that's all we're doing right here. 5 pi over 2, 180 divided by pi, pi's cancel, and I end up with 450 degrees because 5 times 90, If you want to just take 5 times 180 divided by 2, you get 450. That's great. That's greater than 360, so let's just make it a little bit more manageable. And I end up with 90 degrees. Good job, Harley. Okay? So questions on calculating coterminal. means they end up in the same place. You're either going to add or subtract 360 depending upon if it's less than 360 or greater than 360.
Wouldn't you have to multiply 180 by 5?
You can, but then you divide it by 2.
How'd you do this? 180 multiplied by 5
Okay, let's look at the bottom. This is where we're going to utilize our unit circle just for an idea of where an angle is drawn, okay? So what we're going to do here, and this is an introduction to something we're going to be doing next week as well. And right now, what we're doing is we're actually going to be figuring out, actually not today, but it's going to help us get there, the lengths of our sides of our angle measurement. So for instance, if I was to up here, you do not need to put this on your notes. But if I was to draw this 60 degrees here, okay, I know that that is 60 degrees. What I'm doing right now is knowing that that's 60, I'm able to calculate this length and this length and this in order to find my sine and cosine. Okay, so I'm looking for this angle right here. It's called a central angle. It's an angle that's coming out of the center of the coordinate plane. It's coming out of the center, okay? So in order to do that, we have to find what's called a reference angle. So step one, draw the angle that's given on an X and Y coordinate. So using your unit circle, look and see, it's not going to be exact, but where 320 degrees would fit approximately. Where would we draw? Which quadrant does 320 degrees lie in? First, second, third, or fourth? Fourth quadrant, all right? So it's going to be about right there, okay? That's about 320 degrees. And then I'm going to label 320 by doing my little snail around a little bit, like what we did yesterday. Okay, so I know that I start at the initial side, and I rotate around, and I end at my terminal side. Right here is 320. What I'm looking for now is I'm looking for this interior angle, this angle right here that is formed between the terminal side and I'm going to say here the initial side, but it's not always the initial. But what's formed between the terminal side and the x-axis. And I'm going to form a little dotted line to connect the terminal side up to this x-axis. And I want to find this angle measurement here. I do that by taking the angle that I started with, okay? And this measurement here at this x-axis, I heard some of you guys saying it, is 360 degrees, okay? So actually, I should write it like this. 360 minus 320. What's this angle going to be? That is my reference angle. The reason why I have a reference angle is because I'm going to refer to this angle when I need to find the lengths of those sides. And I want to find cosine and sine. We're not doing that yet today. I'm just finding the reference angle. Okay? Let's look at B. First thing I need to do is I need to locate where is 250 degrees located on my unit circle. Approximately. Which quadrant? 250. The third quadrant. And knowing that this is 270 down here, I'm going to come out here. And I know that that is 250 degrees. We start at the initial side, the x-axis, and I rotate down. Now I'm going to draw in my, it's going to be a vertical line going up to the corresponding x-axis. It is always drawn to the x-axis. never over to the y, always the x, because I want to find that angle right there. I want to find the angle that's created from the terminal side to an x-axis. Terminal side to x-axis. Now this x-axis out here is what degree measure? If I go out to the left, what's this degree measure? 180. So now instead of subtracting from 360, I'm going to take 250 minus 180. So it all depends upon where this little line touches. Does it touch over by the 360 or does it touch over by the 180? So 250 minus 180 leaves me with 70 degrees. 70 is my reference angle that I will be using. Again, I'm going to repeat that. We're going to see the purpose of this come next week. It's going to help us again find our sine and our cosine. Okay? 120. A quadrant for 120. First, second, third, or fourth. Second quadrant. Okay, so this is the angle formed for 120 degrees. But I'm looking for this angle down here because if I drew my vertical line down, it touches the x-axis here. I want the angle that's formed between the terminal and the x-axis. I'm actually, right there it is. Why don't you, terminal side of the angle and the x-axis. That is the angle that's created that we want to find. Right there it is. So if you want to highlight that, because that's what we're doing, terminal side to the x-axis. Okay, let's go back to C. Now, this is touching 360 or is this touching 180? 180. So I'm going to take 180 minus 120, and that forms a 60-degree angle right there. Because if you look at it, I've gone 120 degrees. If I go an extra 60 degrees, I've done a full 180. That's how you can look at it. Okay? Now, if the angle, and I don't think we have an example like this at all, if the angle should end up in the first quadrant, if it's less than 90 degrees, if it's less than 90 degrees, that is the reference angle. There's no adding or subtracting that you have to do. So if anything lies in the first quadrant, that angle is the reference angle. Okay, that you get to double dip with that. Okay, so let's look at D. I'm in radians. First thing I want to do is convert it to degrees. So I'm going to multiply by 180 over pi. My pi's cancel. 5 times 180 divided by 6. You should get 150 degrees. So I draw my 150. Is that in the first, second, third, or fourth quadrant? Second quadrant. Okay, so this creates a 150-degree angle. So I want to know, what's the angle created to get me all the way to 180? 30 degrees. So I take 180 minus 150. I get 30 degrees is theta. Okay, let's skip on to F because E and F, believe it or not, have the exact same reference and the exact same angle. So, 2 pi over 3, I multiply by 180 over pi. Cancel, cancel. It's 120 degrees. I mean, this doesn't equal 120. I think it actually equals 480.
It does.
Yeah. But they both, after you subtract 320 from that, you get 120 degrees. And there it is, 180 minus 120. I did not draw that very well to scale at all. This theta is 60 degrees, which is my reference angle. Okay? So for instance, if I had a G down here and it was 75 degrees, you would draw your X and Y. You would draw a 75-degree angle right here. And since that is less than 90, it's in the first quadrant, 75 is also my reference angle. That's when you do not need to subtract from 360. You would actually be subtracting from 0, and you would get the exact same angle measurement. Okay? Any overall questions over that?